In this video, what we are going to do is learn how to apply our significant figure rules that we did in the previous video to our calculations. So what we're going to do is we're going to look at how to round our answers from a calculation. Now, first thing we're going to talk about rounding, addition, and subtraction. So when we round addition and subtraction, we don't even have to worry about significant figures. What we need to look at is how many decimal places our data is expressed to. So if we look at this first example down here, we've got one decimal place, so to the 10th of a gram, 2 and 2. So those ones would both be to the 100th of a gram. You are limited by your least precise measurement. So since there's only one decimal place to the 10th of a gram, that's how many decimals or can be in our answer, or we can know it to the 10th of a gram. So what we do is we just add this up like normal. So we do 2.1 plus 12.59. All right, so we add all those up and we get 49.42 grams. And then again, we have to round it. So since this first measurement, we only know that to the 10th of a gram, that's how precise our answer can be. So our final answer would be 49.4 grams. So again, rounding, addition, and subtraction, we just look at the number of decimal places. We're limited by our least precise measurement. So then in number 2, we have 109.05 minus 62.4 grams, and that gives us 46.65 grams, but we need to round it. Second measurement, we only know to the 10th of a gram, so our answer can only be to the 10th of a gram, so it would be 46.7 grams. Again, because we're going to keep the one decimal place, but there's a 5 there, so we would have to round that up. All right, when we have a calculation that involves multiplication or division, which is going to be our more common calculations, we're going to do the same thing, except we are going to count significant figures. So this is why we had to get good at counting significant figures. And again, we are going to be limited by the least precise measurement. So we are going to multiply those two numbers, so 3.127, and you can just go ahead, put that into your calculator, times 8.01 gives us 25.047 plus a few other digits. All right, so then what we do is we take a look at these values. So 3.127, that has 4 significant figures. 8.01, that has 3 significant figures. We're limited by our least precise measurement, so we can only have 3 significant figures, not 3 decimal places, 3 significant figures. So this is going to round to 25.0. That would give us 3 significant figures. There's only a 4 there, so we do not round up. All right, second one. The mass of a solid is 3.6 grams. Its volume is 1.8 cubic centimeters. What is the density of the solid? So density is equal to mass over volume. So we have 3.60 grams divided by 1.8 cubic centimeters. So we do 3.6 divided by 1.8, and that gives us 2. But we need to take a look at significant figures. So 3.60, that is 3 significant figures. 1.8 is 2. We have to go with our least precise one. So we have to write 2 so that it has 2 significant figures. So that would be our units. So again, your significant figures in your answer need to match the significant figures in the least precise measurement, because you're limited by your least precise measurement. All right, one quick thing that I just want to point out. Sometimes we have exact numbers. Exact numbers are exact, so they have no error. So therefore, they would have an infinite number of significant figures. Um, for example, if we were doing a conversion between, feet and inches, there are exactly 12 inches in a foot. It's not like sometimes there's 14 or sometimes there's 11.5 inches. By definition, 1 foot is equal to 12 inches. So, on something like that, you wouldn't have to worry about significant figures since that's an exact number. It would have an infinite number of significant figures.